You can define diagnostics as being the determination of a faulty function through monitoring and evaluation of the characteristic values of a system. If the evaluation of these characteristic values throws up a critical value, the cause and location of the abnormal state is determined and displayed. In the course of the process, the significant symptoms captured by the monitoring system are analyzed and the cause responsible is determined. Considering that in practice there is a lot of ambiguity between the cause and effect, the diagnostics process can be a very complex one, which is why it is necessary to have extensive know-how and experience in processes and possible faults. Technical diagnostics is integrated in an overall maintenance strategy whose primary task is to ensure high availability, especially in production systems. In the corrective case, in other words when a unit fails, the system must rapidly display the fault, locate its cause as precisely as possible, and support the operator in clearing the fault. The savings potential is highest here because standstill times in the production process can be reduced. The preventive case is based mainly on a time model. Here, using logistics tools based on time intervals, operating hour meters, etc., a warning is purposely triggered and servicing carried out reliably. The consequence here is that you might waste the service life of the unit replaced, because it might well have continued functioning a lot longer. The predictive case is based on a status model. This means that optimally the operator receives a clear and explanatory warning in good time that a fault might occur in a unit or system in the near future, or an indication is given of the remaining expected service life of the equipment. This means that practically all additional costs are eliminated. This case requires extensive knowledge of the process because, to ensure a meaningful prediction, often very many statuses and characteristic values have to be evaluated. In this respect, automatic diagnostic systems based on know-how and status are just beginning to find universal employment in the production industry. The tasks of system and, above all, process diagnostics with SIMATIC, which is the topic of this demonstration system, are for corrective cases. The diagnosis of a fault is normally based on which components of a system or machine are diagnosed. We therefore differentiate between two types of diagnostics: system diagnostics and process diagnostics. System diagnostics covers the monitoring functions that concern the correct functioning of the components in the automation system, which includes everything from S7 CPUs and function modules to network components and intelligent sensor interfaces. If a fault occurs, this could be a programming fault, module failure, access failure, etc. Then this is stored by the CPU in an internal diagnostics buffer. The service staff can run a fast and targeted fault diagnosis via PG functions. Also, the display of system faults on HMI devices requires only a small amount of configuring. In the case of a system fault, the operating system of the CPU interrupts the normal run of the program and automatically calls the appropriate fault OB. The programmer can now selectively react to each system fault individually. Process diagnostics now captures all the events, processes and components going beyond the controller in a system process. These can be defective sensors or actuators, hindered movements, or unfulfilled blocking tasks, for example. Process diagnostics cannot be automated in the same way as system diagnostics. It is system-specific and therefore cannot be built into the hardware or software like the system diagnostics. Process fault recognition requires a different monitoring strategy for each machine or system, and can only be implemented by the manufacturer of the system. The engineering tools support the programmer here by generating an individually monitoring program that is incorporated in the program processing. Integration of process diagnostics into HMI devices requires only a minimal amount of configuring thanks to ready-made standard masks. Let us summarize this. Due to the high hardware availability of today's automation components, the emphasis of the diagnostics must very clearly be put on process faults. The sense and purpose of process diagnostics is to quickly and reliably display the fault and its causes. We will now have a specific look at the SIMATIC products and tools that make process fault diagnostics possible. Process diagnostics in SIMATIC includes different additional products that are integrated by TIA into the individual overall solution via optimum system interfaces. These then provide a consistent interaction between the SIMATIC languages, the options packages, and the HMI